Okay, let's backtrack a little bit here. First, let's look at running Kubernetes locally with minikube. Minikube. And Kubernetes task. So what we're going to be doing here is, oh, there's already a Debian package. Sweet, sweet. I have not yet turned on this box. So let's go ahead and do that. So if you're just joining us, what's going on here is we're about to run a TensorFlow classifier task. We've been increasing the number of cores in this box. We're going to run 16 now. I've been trying to run more, but ran into a quota issue. Increased the global quota, but not the regional quota. Anyway, we created a container for this, and I'm going to run this in. First, it's just going to be command line docker run, but figured why not go ahead and try to use Kubernetes real quick, because this will be more fun. But the question then is, where is the, let's see, Kubernetes run once. Oh, it's a job. It's not a task, it's a job. Kubernetes jobs. Right here. So the only question I'm really having with these jobs is, can I pass in that number of the class index to it? So the output is similar to this. I mean, it might be easier just to go back to using Docker. So I can quickly figure out a clever way to give each job a different class index. Oh, but I don't know, and I think this machine's ready to start. And I'm ready to go ahead and start this process. We could do something silly like just create a, let's see, TTL seconds after finish spec. Like if we made each instance sleep whenever it woke up, and then it looked in the directory of, yeah, it goes through and it sees if a file is already created, and if it is, then it moves on to the next one. Otherwise it uses that file. I think as long as we have sleep and the randomness, like there might be an error somewhere in there, but I think everything should make it. Is there a way that we could get around that error? Like if we had it sleep some random number of seconds between 0 and 30, you have 105 jobs. No two should be starting at the same time. But how could you guarantee no two start at the same time? Like I wouldn't want two to create that same file and have to write to it. But I bet you the file's already going to be in use by one, so that container would just error out, and we could move on from there. All right, what happens if you run two Python tasks trying to write to the same file at the same time? Let's find out. How could I quickly do that? Okay, so we're just going to open up, if I can ever type it, file, and keep writing some stuff to it. File.write I. Might get picky. I want that to be a string, so we're just going to go ahead and make that a string. And also, we're going to go ahead and import time. And we're going to say just some small amount of time. Okay. So then if we run Python, maybe time.sleep is in seconds. Let's find out. Python time sleep. We're talking T, this is the number of seconds. Oh, I should have known that one. So we want to sleep 1/10 of a second. Try that one again. So we're writing the file, stop it, cat the file, there's all the stuff. Okay. So what we want to do is we want to run 2 of these at the same time. Python W, Python W, and both are writing at the same time. I didn't know that would work. Oh. Crap. If we want to get a little bit more complicated, we could just run like Redis, but that's just getting outside the box here. Really, all I want to have happen is to run all these containers at once. Oh well. Handling pod and container failure. Application controller cron jobs, handling pod container failures. Let's at least start somewhere fun. Get that running. This needs to be running. Is it mad again? No, there we go. So we'll install minikube, and then we'll try to run jobs. Cleanup, finish jobs, job termination, cleanup. So really the only thing that's getting me right now is I want each container to be able to grab a number between 1 and 105, 0 and 104. What am I missing to do this? Or let's just throw in Redis real quick. Because you want the container to jump up, grab a number, check if that number is being ran yet. If not, run it. If it is being ran yet, go again, find another number. So I really just need Redis for this. I don't know of a way to do it without. So I also have to access the local host from there, from the container that's running. And what's the way to do that? Well, do we dive down this hole and find out? Do I just run this task? Let's find out. Let's find out that maybe I can make a nice clean video about how to do this. That's the thing I'm running into here. Some videos are kind of like long and drawn out, and I'm not sure what to do, and have to look around at some things. Which really, that's the majority of programming, right? You need to be dynamic and be able to move around, be able to change your mind on what you're doing. Yeah, because you're going to keep encountering things that you didn't expect. Or if you did expect them, then you spent too much time planning it out. Alright, so installing minikube. Alright, minikube is set up. Alright. So package did that run too? Yep, cool. So what comes after installation here? Minikube start. Okay. So it's going to be doing some things to start this up. And then I do want to run this. So the other question is running Redis. This is going to be some more exploration because, well, I haven't really worked with Redis that much. Like I have before, like a year or so ago, for a one-off task, but I couldn't tell you one of the commands for it off the top of my head. You would think I would just run a Docker container for it, or, you know, a Kubernetes service. Well, we're going to be nice and easy right here and just set up a local Redis server. And then we're going to see if I can interact with it with Python, how that works, and then see if I can interact with it in Python from one of these jobs. And then we will actually run all of these jobs. While we're waiting on all this, why don't we go back to the quotas and increase, or request an increase in the US Central 1A CPU quota. Google, this could be a little bit easier or more straightforward. Like, hey, this quota is going to rely on this one, and you're missing it. The limit name, CPU. Committed CPUs. US Central 1. Doesn't make any sense. Oh. It's not committed CPUs. The wrong limit there. It's something CPU. What does I CPUs? There it is. Boom. Boom. New limit, 96, please. Alright, let's see if I can remember how to spell this one. OCCASIONAL. An occasional data processing task. Recent. global CPU quota. Boom, boom. All right, where are we at over here? Minikube's installed. Redis is installed. Redis. Cool. It's already running. So if we go into Python, install a little Python thing for it. If that works, then we also need to do that in our Docker file here. And you see what we're doing here, right? It's just to we're using Redis in order to store pretty much the queue, so that way whenever an instance pops up, it has a place to ask and say, hey, what jobs do I need to run? And then it can grab it and then move along. So we installed that there, installed this here. We're going to run Python 3. And then come back over here with the Redis stuff and learn Redis real quick. Redis. 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 I'm sure these are all the defaults, but it's good to learn them. 6379 and db equals 0. I didn't know that you could have multiple databases like that. All right, r.set tasks. Okay. There's a way, right? I think. Redis list. That's really what I'm wanting right here, right? Redis list pop. What? My list. Client, I'll push. Class indexes, what are we going to push? 0. R dot L POP. Yep. R dot L POP. What are class? ID access. Okay. So if I wanted to populate that, we could say for I in range 105 R dot L push I. Wrong number of arguments for L push. Oh. I would have read the first message, we would have seen that, right? Okay. So if we want to see it, we do r dot ln class indexes. Okay. So cool. Next question is, let's create that YAML for the job, which will look like this. name is going to be classy. What's classy going to do? Container name classy. Image. I'm going to guess I can pull a local image, and that local image is called classy. I don't think I need that. I don't think I need that. I want it to run once. Active deadline limit. Where is... Specify a non-zero positive value for spec.completions. So spec containers. Jobs with a work queue. Themselves in order for external service. See? That's why we just made Redis. Each pod is independently capable of determining for non-parallel jobs a parallelism. Alright, so that's the other thing we need to set here is parallelism. Alright, that's just gonna be one. Okay. What do you think? Is this going to work? We're going to build classy again. That's why I should break all those out. Let me break those out real quick. See all these things that we have here? Well, we're having to go through and reinstall like everything because these are all on different lines. Well, okay, so there's all of our requirements, and now one on each line, as it probably should be, so that way you can go back through and fix that. Oh, we have no space left on the device. Uh-oh. Oh, this drive's only 25 gig. Oops. Okay. Well, how can I improve that? Docker prune, isn't it? Docker system prune. There we go, 2 gigs back. This is one challenging thing whenever you create a cloud instance. I guess it's really nice that it's a cloud instance, but you know, you're setting your hard drive size compared or based on how much you want to keep spending continuously on that drive. And so I have a separate data drive for all the data for processing, but I hadn't considered these containers, so I just set like the main OS partition to be 25 gigs, and Docker filled that up. Anytime that I run out of space, it's Docker. Then you go run this Docker system prune, and you're like, oh wow, there's 32 gigabytes. I was wondering where that was. Anyway, so this is running now. yeah, we'll come back and see how it's going. Hey, hello and welcome back. So we're working on parallelizing that process, right? We've created a Docker container for it. And now we need to run that container multiple times and have it classify all of our data. We need to go ahead and make this into a container because if you try to parallelize this in Python, it gets angry. It doesn't work right, especially inside of a notebook. Inside of a Docker container keeps TensorFlow isolated in each instance, so we can start many of them at once. It's nice and scalable this way too, because right now we have 105 classes and we're going to limit it down to like maybe 50 audio files per class, just to make sure this is working right and all. But if we had more audio files and we needed to scale this up more, we wanted a Kubernetes cluster to run this on, if we wanted to run 10,000 instances of this, yeah, we already have it containerized. We can do that. It's nice and easy. So I was running into one issue because my VM is only a 25 gig VM here, even though I have like a 250 gig SSD drive attached with the data. And I was running out of space for the Docker container because it installed minikube, installed the GPU stuff, installed enough stuff to take up that 25 gig. So the answer there was to remove the Docker directory and remount it from the data directory. So now let's see if we can actually, again, build that classy image. Unable to prepare context, unable to evaluate system links in Docker. lstat Docker file, no such. Oh, well. How about we go to the correct directory and run it? So this is going to take a little while, again, but it's a container, right? That's what we do. We build it once, and then, you know, some stuff screws up, and you might build it again, but it's all there, and it's so much easier than a Puppet deploy or Vagrant or any other crap. That's why containers rock. Anyway, so that's building. While that's building, let me share the other things. We have minikube. We've installed that. Up here from this, just if you go to the minikube page, it has it. How to install it. I use the Debian stuff. We started it, and that downloaded Kubernetes and ran it. I haven't ran this yet, but I should be able to run kubectl git pods. Nope, not yet. Snap install kubectl. This revision of snap kubectl was published by Classic. If you understand and want to. Watch this. kubectl Ubuntu. Or maybe I just keep going with this. Classic. I've never used snap before, so this, you know, we'll see what it does. Okay, that was easy enough. Now can we run git pods? Connection was refused. So there's got to be a way to wrong doc. Where's that? Oh, it's over here. Minikube can download the appropriate version of. Oh, should have just read that. Cube Docker. Okay, so that's because I minikube start. There's an image for it that has to pull. That makes sense. Git po-a. If you already have it installed, you can access it. Use the shiny new cluster. So we're installing it, and we're going to see how it works. We got our container created here, and I had one question before. I think it was in the previous video, maybe the one I deleted. The host. So that's our host. We can run it in one of these job containers. Like we go to vim classifier. We're at the top now. Let's go and put in our other updates. we're going to import Redis. And right here, we're going to say r equals Redis dot Redis port. What port is Redis? 6379. And db equals 0. Okay, and then were we originally over here? Where's our class index grabber? This thing right here. Class index. This is our new class index. It's r dot lpop class indexes. And let's make sure that comes off as an int. And we should be good to go. There's minikube running. So let's go back to that page. The resource is found in the default namespace. Okay, but at least it's running. So if I run get nodes, boom, shakalaka, minikube. Sorry, had to. All right, back to the job. Boom, 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 boom. Let's see if we can run this. Cube, CTL, apply, -f, job, YAML. I'm gonna want the output from it though. Let's see how I can get this. Job spec, unknown field, completion, COMPLETIONS. So maybe, oh, it's in the wrong spec. Boom, boom. Boom. Successful create. I'm gonna get the job output. Logs. That's it. Okay. So if we go back over here, let's make sure that we have the right version installed. Weird. So, must have been for a different version. Or I'm messing something up right there. Oh. Font is shown under events. Boom. Thank you. So waiting to start, trying and failing to pull image. Minikube, pull local image. Boom. Check that out. I was doing it wrong. So how about we update that job? Field is immutable. Okay. How do we do this? kubectl, get jobs, kubectl, delete job. Apply the job. Describe the job. This is why I love Kubernetes though. Like, we're doing a lot of different things right there. Those little commands. It's just really quick and easy. Same pod is waiting to start. Trying to available image. Come on now. Build the image with the Docker daemon of minikube. Do I have to build it again then? I do. Okay. Set image pull policy to never. Boom. Okay, so we're again installing our libraries, prerequisites, TensorFlow stuff. But I like the way that this is set up, right? So let's look at this. Let's look at this. What have we got going on here? What have we got going on? We need to run this container multiple times. So we have created a job spec for Kubernetes to run it multiple times. We're just running this on one VM. We don't have an actual legit Kubernetes cluster to run it on right now because this is still in, this is minor development. We're just testing things out. We have small limits on stuff. So we're running this on just one VM, just, proof of concept kind of. Not really. What would we call this? Stage 1. Yeah, we're running this on a VM to test the stage 1 data processing. Next, we could always run this on a larger cluster. We could run 10,000 of these at once, nice and easy, because Kubernetes is scalable. A job spec here is scalable. All of these items, they're scalable. So now, let's see if this works. What are we going to do? We're going to get our jobs. We're going to delete this job. Ha, metaphor for life. We're going to come over here to apply the job. And it's mad because image pull policy, if you choose to ignore these errors, turn validation off. Why is it mad? Unknown field, image pull policy. Did I write that in the wrong place? Or did I misspell it? IMAGEPO. Is it happier with that? Boom. Okay. Again, let's go back up and describe that classy job. All right, little man, getting there. Where are we at? What was wrong? During handling the above exception, another exception occurred. Connecting to host, name or service not known. Host minikube internal. Well, I would have expected something different from that. Host minikube internal. Name or service not known. SSH. I mean, that's a lot of silliness. Oh my goodness. So I'm gonna guess that minikube can access this. Vim. Over here. What do you think? There we go. That build went a lot quicker. Get jobs. Delete job. Apply job. Describe job. Get the logs. L8 SW7. No, didn't like it. Crapoli. Well. So that in your pod host file there isn't any minikube entry. Host alias at the point of pod manifest. Minikube IP. Okay. Just need that IP address. Just need a way to get to it. Because so I just want to run a Kubernetes container on minikube. No, I meant Kubernetes container, a Redis container. Not Redis. It's time for more copy. Copy, my goodness. More coffee. going to pause for just a moment.